Okay, so we finally made it to the birthday project after me talking about it all year. And the purpose of this video is to take you through the design specifications of the project, as well as through a pretty detailed example. So you can refer back to this video, or you can pull the PowerPoint yourself to go back and look at this in more detail as you're working through your own project. So here are the design specifications. You're going to design a combinational logic circuit with the following design specifications. It is going to have 3 inputs and 7 outputs. The 3 inputs are going to be 3 switches, and they will count from 000 to 111. Okay, so you're basically going to count from 0 to 7. And so there are going to be 8 different combinations. The 7 outputs are the 7 segments on a 7-segment display. And so as you go through the switches, the idea is that you are going to display your birthday in month, day, year format. So if you're used to doing day, month, year, which is what like a big chunk of the rest of the world does, but we don't. We do month, day, year. And so, for example, when you have the switches at 000, it's going to display the first digit of your birth month, which is either a 0 or a 1. And then when you go to 001, it's going to display the next digit, and so forth. And then it'll display a dash, and as you go through, and by the time you're at 111, it should be displaying the last digit of the day that you were born. So that's the end game, is to have that circuit. So this is the example that they provide, and they go through a lot of detail with this. So they're using the date of birth 0213 1910, which is the birth date of William Shockley. Shockley, along with John Bardeen and Walter Brattain, invented the transistor. So there you go. So pretty much for this particular birthday, this is what we would want to see. When the switches are all off, it's going to display a 0. When the switches are at 001, it displays a 2. And then as we're counting up in binary, we're going through the birth date. And so as the switches go, we'll see the birth date go on the 7-segment display. There we go. Okay, so what you will do is you're going to do this for your birthday. So unless we have people in the class that have the same birthday, you are all going to be working on a different circuit. Okay, now you might have overlapping parts, and it's okay for some collaboration, but and you might have like a birthday that works out really well. Mine did not, and I know I've probably mentioned that in class. My birthday was just not very cooperative, and mine has a lot of the same pieces in it as this one does. I'm 0215, and then obviously I was not born in 1910 or 2010. But so what you'll do is you will start your truth table by setting up your 3 inputs and counting from 0 to 7, and then indicate what you need your 7-segment display to show. And when I did mine, I can go and look at mine in my notebook and share it with you guys, but you're going to want to have that information fairly handy about the 7 segments and which one is A, which one's B, and so forth. It's just not what you want to be looking up all the time, so you want to have it handy. And so what you're going to do is, because it's not like one output is one digit, one output is one segment. And so you might look at, where's my cursor thing? Okay. So you might look at segment A. No, hang on. There we go. Okay. I believe that is segment A. And so you just look at this segment and you say, okay, when do I want segment A to be on? Well, I need segment A on in the 0, in the 2, in the 3, and down here in the other 0. So your truth table for segment A goes 11001001. So you want segment A, that very top part needs to be on for these digits and then off for the others. You don't want that segment lit up. And what you'll do is you'll go through each one of the segments. So if segment B is over here, like, when do you want segment B on? Well, you want it on for the 0, you want it on for the 2, you want it on for the 1 and for the 3 and for the 1 and for the 0, and then you would fill in zeros, and you'll just go through the whole, like all 7 segments that way, and you're going to create a big old truth table. Okay, and this is the one that I just filled in. Okay, so I did this. It shouldn't take you too long to do it, but I would give you this piece of advice. Take it slow and turn off the music. Just make sure you concentrate, because there's so many pieces to this particular project that if you get something wrong, it can be awful to go back and try to find the mistake. So it's really, really going to be worth it to take it slowly and be very thorough with it. Just don't be distracted and doing half a dozen things while you're also trying to do this. Like, give your attention to it. So you will fill in your truth table. And remember, your truth table is going to look different from somebody else's truth table. We the year that I'm recording this, okay, which is the first year we're teaching it, we did have 2 people that had the same birthday in the class. I think one of them dropped. So, but I don't remember. So I don't know. Maybe you might get lucky. You might have somebody with the same birthday as you. Okay. Then what we do is we have to go through each of the 7 segments individually. So we would do a K-map just for segment A. And you would set this up with like your 0, 0, 0 is X bar, Y bar, Z bar, and so forth. And they're using like nice different colors here. Okay. And looking for your simplified Boolean expression for segment A. And so we have a group of 2, we have a group of 2, we have this rogue 1 here that doesn't group with anything. This group is X bar, Y bar. This group right here is, what is that? Z bar, Y bar? Or Y bar, Z bar. And then this one is all by itself. So underneath my face there, it says A equals X bar, Y bar plus Y bar, Z bar plus XYZ. Okay, which is this one right here, and it doesn't go with anything else. And that's your simplified Boolean expression for segment A. And you will need to do that for all of the segments. Okay, so I guess what they did here was they designed the circuit just for segment A, and they're using AOI logic with your inverters and AND gates and OR gates. Okay, and that's going to be your logic segment for segment A, and that's going to go into your 7-segment display driver to indicate when you want segment A to go on. Okay, so that's your logic for that. And then we repeat the process for segment B. So you're going to have 7 Carnot maps, 1 for each segment, and 7 chunks of circuitry. Okay, that's what we're going for there. It's a pretty big, heinous circuit. I don't know if I still have it saved on my Multisim account or not, but I do have it on YouTube, so we'll get there. All right. And again, I can't emphasize this enough that you want to take this slowly. Don't rush it. Don't be careless. Keep your work really neat and really organized. So if you tend not to be neat and organized, and then you go to build this and something doesn't work, you have to leave a trail that's going to be followable and you're able to go back and find your mistake. Now, for segment B, you'll notice that this was implemented in NAND logic only. So this is another skill that we've covered where you take your AOI logic and then implement it with only NAND gates. And that is a requirement for this project. So one of your segments has to be implemented with NAND gates. Any segment you want, but it's got to have a segment in there that's done only with NAND gates. You can do it all. Like, well, no, you can't, because there's another requirement here. But you can do as many segments as you want, except for up to 6 in NAND gates, if you want to do them in NAND gates. Okay, and then we're going through the K-map here for segment C. And simplifying the circuit for segment C. And segment C is being implemented with NOR logic. Now notice that doesn't include the inverter. So you have to get your like inverted signal for all of them regardless. So this is your NOR logic, and one of your 7 segments needs to be done with NOR logic. I hated that requirement because the way that mine turned out, like I could have saved so much space if I hadn't had to like dedicate one segment to just NAND gates and another one to just NOR gates. But that is a requirement of the project. It's a skill that you should have. And so you can simplify that and then implement one of your segments with just NOR logic. Now, then they jump through. Okay, now here's where this one comes in really, really nice. This particular one, when they did the simplified expression for segment D, it turned out to be exactly the same as segment A. And if I can't click back to look at the truth table, but you might have like identical truth tables, so you want to be aware of that. And if that's the case, that's awesome. You only have to design 6 like pieces of circuit. If you have duplicate things, so maybe you have 3, or you have like A and D are the same and B and G are the same, then you'd only have to design 5. So you want to be aware of that, because then you can design 1 circuit and just run it into 2 segments on the driver. My birthday was awful. Okay, it was absolutely awful. Nothing simplified well. There wasn't a good candidate for like the NAND only. And I prefer the AOI. I think it's just easier to get my head around. The NAND, we know that it can be more cost effective, but it's also a pain to do the extra design part on that. But mine had no duplicates. Every step along the way where something could have gone well, it didn't. Now, here are some other things to note, though, when you're designing your circuits. If you stay organized and stuff, like if you look at A, B, and E, they all have X bar, Y bar, X bar, Y bar. Well, okay. So what you can do, if you can keep yourself organized enough, is you can build one X bar, Y bar, and then run it into like the 3 separate segments of the circuit. Now, keep in mind, like one of those segments you're going to need to do with your NAND and one with the NOR. So what I would do looking at this is I might say, okay, well, I've got these duplicate pieces in here. I'm going to, save those for my AOI logic, and then I'll do, something like this that doesn't really match up with anything, and I'll do my NAND gate on that because it's not going to interfere. But like mine, it was just it was just but I did get it right, and I got it right on the first try, partly because I had experience doing this, so like I'm not brand new to this process, but also because I was really organized, and I know I've shown you guys my notebook where I have, really detailed, like things are color coded, and I have the gates labeled and what I'm going to put into which chip and all of that. So the more organized you can stay, the better this will go. So this is the completed circuit. Mine was way, way, way messier than this. Like mine was huge. But notice a couple of things about the circuit here, okay? They don't have it running. Oh, no, you don't have to run it through the driver. We're good. So I forget I said that. You don't have to run it through the driver. You can run it straight to the 7-segment display. So what they did over here was that you have like your X, your Y, and your Z, and then they have the inverted line, okay? And then they're running that line straight down on the left-hand side so that they can tap into it for all of their circuits. I think I used a bus for this. We'll take a look at my circuit in a second, but I think I used a bus to like save time. The other thing I would strongly encourage you doing is color coding the different segments. So if this is like segment A, and notice this was segment A and D, so once they designed the logic, they could just run it to 2 different pins. But do this in one color, and then do the next one in another color, and the next one in another color, to try to keep them looking different. You might run these vertical wires in a different color so that you can see better like what you're actually tapping into. So use all of the skills that you have for designing the circuits when you're putting this together. And then this is mine. Yeah, I used a bus in here, okay? So I can't really zoom in and show that to you, but yeah, so there's the switches up at the top. So I got my power and my ground. Let me put the pointer back on. The power and ground, And then I took, and then here's everything, my switches, and then we have everything being inverted. And then this like really thick looking wire here is what's called a bus. And you can run a whole bunch of things into that bus, and it should turn like a diagonal, like when you do that. And then what that allowed me to do was, instead of having 6 wires over here on the left, I just dumped them all into the bus. And then when you're running your wire into the bus on the other side, you can choose which one of those you want to tap into. So that was just a design choice that I made. And you can tell my circuit is obviously a lot more complicated than the one that we just looked at, and it's going way off of the screen here. It was just really bad. And then we're over here displaying the number 2, which is my birthday starts with 02. So this is the second one, and there's a link to the YouTube video so you can go and watch this work and see how it's supposed to work. And then we were doing this virtually, so I also had to Tinkercad it. And then so we have the power display, here are my switches, and then here's the 5 because my birthday starts with 02-15. So I just kind of grabbed this, but you can check out the link to that. We'll probably look at it in class as well. This, what they provided us with like a template in Tinkercad for us to use, and I'll see if I can find that so I didn't have to set everything up. Now everybody's like chip circuitry in there is different, but everybody has certain things that are the same. Like everybody's going to have a 7-segment display wired to power and ground and stuff, and everybody's going to have all those resistors, and those resistors are going to run into your like ABC. Everybody's going to have the switches, and everybody's going to need the inverter on that. So so there are certain things that everybody has, and then how many chips you use, that's going to vary like from person to person depending on how friendly your birthday is. And then you can tell on this too, this is one of my better ones and it's still pretty bad, but you could tell that I did try to color code it. You could tell there's like blue, and then we have some red, and we have some yellow going on up here. I think there's some white in there to get it to work. And you really have to be so careful about the pins on your multisim and your pins on your Tinkercad. We have gotten most of our chips at this point for the digital logic, so we might be able to do some physical breadboarding with this, but I'm not 100% sure. And we obviously need like a big breadboard to do this, and I'm not sure that we have like the space on the breadboards that we have. But I am open to somebody doing a physical breadboard instead of a Tinkercad. So this hopefully gives you an idea of what this project is, and we'll take it from there in class.